Welcome to Void Realities, a space between waking and dreaming where sleepless thoughts find a home. Here the universe speaks in whispers, and every question becomes a gentle doorway into the night. The chemistry of nearly everything, the breath of atoms. You begin with the smallest building blocks drifting like dust in a sunbeam. Atoms whisper their presence through weightless dances of protons and electrons. You feel the stillness of the air, yet inside it, countless particles move with quiet urgency. Every breath you take is a symphony of invisible chemistry unfolding within you. You sit in the quiet, breathing slowly, and the room feels still. But the stillness is an illusion. All around you and even inside you, there is motion too small for your eyes to catch. The air that slips in and out of your lungs is not empty. It is alive with countless tiny dancers. You cannot see them, yet they are the foundation of all things. Atoms. An atom is a whisper of matter, the smallest piece that still holds its identity. Hydrogen, carbon, oxygen, names you've heard in school, on labels, in science books. But tonight, in the quiet of your resting mind, you meet them again as companions, not as terms to memorize, but as little stars of reality, drifting like dust motes in light. Picture one atom, so small you could line up millions across the width of a single hair. At its heart, a tiny center called the nucleus holds nearly all its weight. Protons, positively charged, and neutrons without charge sit close together. Around them, electrons trace invisible paths, like fireflies circling in the dark. This is not a machine, not a miniature solar system, but a living metaphor of balance, pull and push, attraction and distance, the dance that keeps it whole. Your breath now feels different when you notice this truth. Every inhale is not just air, but streams of atoms, oxygen molecules rushing in. Each exhale releases carbon dioxide, the chemistry of your body leaving gently into the night. You are exchanging pieces of yourself with the world in every soft breath. This quiet exchange has been happening for as long as life has existed. Atoms are patient travelers. The oxygen in your lungs tonight may once have been part of a tree in a forest, feeding leaves as they reached toward the sun. The carbon leaving your body may once have been buried in ancient stone, or floating in the ocean, or carried in the breath of someone long before you. You are connected, in a very real way, to every living and non-living thing, because atoms wander without end. Close your eyes and imagine the air in your room as a hidden sea. Every cubic inch holds trillions upon trillions of atoms, bumping, colliding, rushing, slowing, then drifting again. Though you cannot hear them, their collisions create pressure. The reason air presses on you from all sides. Though you cannot see them, their speed is astonishing, moving hundreds of meters per second, yet all you feel is calm, because they are too small to touch your skin individually. Now turn inward. The body you rest in is itself an orchestra of atoms arranged with care. Your skin is woven from carbon, hydrogen, oxygen, arranged in long chains we call proteins. Your blood is carried by iron atoms at its core, each one catching oxygen like a net and releasing it where it is needed. Even your thoughts, the drifting flow of words and dreams, emerge from electrical pulses, tiny currents made possible by electrons. Atoms are not distant or abstract, they are you. And yet, you are not only made of atoms, you are their movement, their story. They bind and unbind, they share and release, and in that endless dance arises everything you know. Atoms alone are silent, but together they become a voice. The breath of atoms becomes the chemistry of life. Think of a glass of water. It looks so simple, so ordinary. But what you drink is billions of H2O molecules, 2 atoms of hydrogen clasping 1 atom of oxygen. The bond is not random, it is attraction, a tiny pull between positive and negative charges. When enough of these bonds gather, they form liquid water. The substance that flows through rivers, fills clouds, and runs through your veins at this very moment. And in the flame of a candle, you see chemistry's other side. Atoms rearrange themselves, oxygen mixing with carbon, releasing heat and light. This is not destruction, but transformation. Atoms are never lost, only reshaped, forever finding new partners, forever whispering new stories. The universe itself is built on this rhythm. In the beginning, only hydrogen and helium filled the cosmos, born in the great expansion we call the Big Bang. But deep in stars, atoms fused, hydrogen into helium, helium into heavier elements, and so the stars became forges. Carbon, oxygen, nitrogen, iron, the elements of your body were made in their fiery hearts. When stars died, they scattered their treasures into space, and from that cosmic dust, your world was born. So when you breathe stardust. The atoms you carry are billions of years old. They have passed through stars, oceans, stones, forests, and bodies. They will continue their journey long after your rest. You are part of an unbroken chain of matter. Let your mind picture this. The room you lie in is a cloud of invisible particles, walls, furniture, your own body, all solid, all heavy, yet all built of mostly empty space. For inside each atom the nucleus is small beyond imagining, and the electrons are like faint shadows at great distance. If an atom were the size of a cathedral, its nucleus would be no larger than a grain of salt. Everything you see, everything you touch, is a vast openness held together by invisible forces. There is a calm in knowing this. The solidity you depend on is the result of delicate balance, repulsion and attraction, emptiness and fullness, a constant breath that makes the world stable. Your bed, your body, the air, the stars, all are woven from the same invisible threads, and as you rest, you may begin to sense the rhythm. Each atom in you is moving, vibrating with thermal energy, trading electrons, forming bonds, breaking them again. The pulse of your heart, the warmth of your skin, the gentle sigh of your breath. All of it is chemistry in motion, atoms working without pause, without end. As you drift deeper into stillness, you might ask yourself, what makes one atom reach for another? What invisible hands pull them close or push them apart? The answer lies in bonds, the next part of the story, where atoms hold, share, and release one another to form the endless shapes of matter. Bonds that hold the world. You imagine hands reaching out in the dark, grasping and letting go. Chemical bonds are the touch of atoms, the invisible glue of existence. From water's soft embrace to the sturdy lattice of stone, bonds decide form and flow. The world around you is made not only of matter, but of connection. You are surrounded by atoms, tiny, restless travelers, yet their story is not complete on their own. An atom can exist alone, like a solitary note in silence. But the true music of matter begins when atoms join hands. This joining, this invisible grip, is what we call a chemical bond. It is not merely physics, not merely force, it is attraction, balance, and sometimes even tension. Without bonds there would be no water, no stones, no breath, no body. Imagine two atoms drifting near one another. They sense each other's presence, not by sight, not by touch, but by the delicate pull of charges. Electrons, those flickering negative sparks circling an atom's nucleus, feel drawn toward positive centers. If one atom can share or attract another's electrons, a connection forms, an invisible bridge across the emptiness. This is chemistry's first poetry, the covalent bond. It is sharing as if two atoms clasp the same electron in their hands. Hydrogen and oxygen perform this dance when they form water. Each hydrogen offers its single electron, oxygen extends its own, and together they share. It is a quiet act, but it gives rise to oceans, rain, blood, and breath. Every droplet you sip is built upon these tiny handclasps. Other times atoms do not share, they give and they take. Sodium, with its lone electron dangling like a gift, hands it to chlorine, who hungers for just one more. The bond that results is ionic, an act of generosity and need, a giving away and a grasping hold. The salt you taste on your tongue, the crystals that crunch beneath your teeth, are made of these simple exchanges. And then there are the bonds that are less like handclasps and more like gentle attractions. Hydrogen bonds, subtle, fleeting, but powerful in their numbers. A water molecule, with its bent shape and uneven charges, leans toward its neighbors, its oxygen slightly negative, its hydrogens slightly positive. They cling for a moment, then let go, then cling again. It is this restless web of bonds that allows water to bead, to flow, to hold warmth. Without these fragile ties, there would be no rivers, no cells, no life. Pause for a moment and breathe. You are held together by bonds at every level. Proteins in your body coil and fold because of them. Your DNA, the spiral staircase of your genetic code, is zipped tight by hydrogen bonds, unzipping only when your cells must read the script of life. Even your bones, strong and enduring, are lattices of calcium and phosphate bonded into minerals. Your body is not just atoms, but atoms in conversation, atoms holding one another. The world beyond you also speaks this language of bonding. Stone is the Earth's testament to strong, repeating bonds. Silicon and oxygen bind in a vast, intricate network, forming quartz, sand, and the glass in your window. Metals shine and conduct electricity because their atoms loosen their electrons into a shared pool, like a community holding its resources together. This metallic bond is what allows copper wires to carry current and steel beams to rise into the sky. As you drift further into thought, you begin to see bonding is not uniform. It is diversity that makes chemistry so abundant. Some bonds are weak, some are strong, some hold only for an instant, and some last for billions of years in the stability of stone. Like relationships in life, they vary, but together they build a world. Consider ice. When water cools, its hydrogen bonds lock into place, creating open spaces that make it lighter than liquid water. This is why ice floats, why ponds freeze on top, sheltering fish below in winter's stillness. One subtle feature of bonding changes the fate of entire ecosystems. Now think of carbon, the most versatile of all. It can form 4 bonds, stretching out like a hand with 4 fingers. Because of this, carbon builds chains, rings, and frameworks, the backbone of every living molecule. From sugars to proteins to the DNA that writes you, carbon is chemistry's artist. Its bonds allow life to sketch itself in endless variation. As you lie here, you may notice how quiet bonding is. There is no noise when atoms share or give or attract. There is no flash, no visible spark. And yet this silence is the heartbeat of existence. Every cell in your body is a library of bonds forming and breaking. Every material you touch is a result of atoms clasping together. The world is not a pile of separate grains, but a tapestry woven of connections. The gentleness of bonding carries into your senses as well. Taste is chemistry, sourness, sweetness, bitterness, all are signals of molecules binding to receptors on your tongue. Smell is chemistry. Fragrant or sharp molecules slip into the folds of your nose, binding to tiny proteins that awaken memory. Even vision, the most radiant of senses, depends on bonds shifting shape inside your eyes when photons of light arrive. Every color you see begins with a bond breaking or twisting, releasing a signal to your brain. And so bonds are not far away, not abstract. They are in your breath, in your sight, in the smallest sensations that make your night real. In the stillness of the room, you may imagine countless hands reaching and letting go, a universe woven not of solitary points, but of endless invisible embraces. Atoms seeking balance, atoms finding companionship. This is why matter endures, why life blooms, why the world feels whole. And yet these bonds, as sturdy and vital as they are not the end of the story. For even when atoms and molecules are held together, their story changes when energy arrives. A spark, a flame, a ray of sunlight. Energy disturbs the calm, shaking bonds apart or forging new ones. Where bonds decide structure, energy decides motion, transformation, fire. The alchemy of water. You picture a droplet glistening, its molecules locked in a delicate dance. Water is softness and strength, able to dissolve mountains and cradle life. Its chemistry whispers through rivers, oceans, and the beating of your heart. You are mostly water, and so is the earth. You hear it in the rhythm of rain against glass. You feel it in the cool touch against your lips. You carry it in your body, flowing in your veins, surrounding each of your cells. Water is not only something you drink or wash with, it is the medium of life, the quiet ocean inside you, and the most mysterious substance you meet every day. Take a moment to imagine a single drop of water. It gleams in the light, transparent, fragile, fleeting. Yet within that droplet lies chemistry's finest alchemy. Each molecule is made of 2 hydrogens and 1 oxygen, H2O. A simple formula, so familiar it might feel ordinary. But nothing about water is ordinary. The oxygen atom in water pulls harder on electrons than hydrogen does. It keeps a slightly negative charge, while the hydrogens grow slightly positive. This imbalance creates polarity, like a tiny magnet with 2 poles. Because of it, water molecules are drawn toward each other, clinging with hydrogen bonds, forming networks that shift and rearrange. Every sip you take is a fabric woven from countless invisible embraces. This simple feature, the polarity of water, creates a world of miracles. It is why water is liquid at room temperature, when similar molecules like oxygen gas or methane drift away as vapor. It is why water can dissolve so many substances, from sugar to salt to the nutrients your body needs. It is why rivers flow, oceans churn, and cells survive. When you drink, water moves through you with ease. It dissolves salts, sugars, amino acids, carrying them across cell membranes like an invisible courier. Every reaction in your body, from digesting food to sparking thought, depends on water as a solvent. Without it, the orchestra of life falls silent. And yet water is more than a solvent. It is a shapeshifter, a master of states. It flows as liquid, rises as vapor, hardens as ice. Each change is chemistry in motion, molecules speeding or slowing, bonds forming or breaking. You witness it each time you watch steam drift from a kettle or ice crack beneath your feet on a winter morning. But even here, water breaks the rules. Most substances grow denser as they freeze, but water expands, becoming lighter as ice. This is why ice floats, why lakes freeze at the surface, protecting life in the depths through the coldest winters. A fragile quirk of hydrogen bonding becomes the reason ecosystems endure. Water is also a keeper of heat. Its bonds allow it to absorb and release energy slowly. This is why coastal air feels gentler than desert heat, why your body can regulate temperature through sweat. The oceans breathe with climate, storing warmth and releasing it in waves and winds. Without water's patience, Earth would swing wildly between extremes. Let yourself wander to the scale of the planet. 70% of Earth is covered in water, shaping its surface, carving valleys, smoothing stone. Rain falls, rivers run, glaciers grind mountains to dust. Water is not only gentle, it is power, patient enough to wear away peaks, strong enough to split rock with ice. Now return to yourself. You are a reflection of the earth. More than half your body is water held in blood, tissues, cells. Your brain, the seat of your thoughts, is mostly water. Your eyes, your skin, your very breath, all are kept alive by its constant flow. You are a moving tide, a walking ocean shaped and sustained by chemistry's most humble miracle. Consider the blood in your veins. Water carries red cells floating like boats, each filled with hemoglobin holding oxygen. Nutrients dissolve in water. Hormones drift through it like messages in a current. Even waste is carried away by water's flow, leaving your body clean and balanced. You are never separate from rivers and seas. They echo within you every second of your life. And in your thoughts, water plays a quiet role. Electrical signals in the brain depend on ions, charged atoms like sodium, potassium, calcium, sliding across watery channels in neurons. Your ability to remember, to dream, to fall asleep is shaped by the movement of water and ions together. The mind you use to imagine is, at its heart, fluid. Now imagine water not as a substance, but as a storyteller of time. In clouds it drifts freely across the sky. In rain it falls, eroding stone, nourishing soil. In rivers it travels, carving landscapes across centuries. In glaciers it freezes, holding memories of ancient air. And in oceans it circulates endlessly, currents driven by temperature and salt, linking distant corners of the planet in one vast breath. Even beyond Earth, water's story continues. On Mars, ice hides beneath red soil. On Europa and Enceladus, moons of distant planets, oceans lie beneath crusts of ice, raising the question of life beyond our world. Everywhere water flows, life becomes possible. The alchemy of water may not belong to Earth alone, but return now to the drop you imagined. It clings to a leaf, quivers, falls, joins others in a stream, a river, the sea. One molecule may journey for centuries, evaporating, condensing, freezing, melting, moving from clouds to soil to ocean to body. The water you drink tonight may once have filled the belly of a dinosaur or drifted as vapor over an ancient sea. Water does not vanish, it cycles endlessly, a circle of chemistry connecting past and present. Pause and hold this thought. When you drink, you are touching history. When you breathe in mist or step into rain, you are part of a cycle older than life itself. Water is memory, movement, transformation. And so you lie here, listening inward. The flow of your blood, the breath in your lungs, the sweat cooling on your skin, all are the alchemy of water in motion. Every part of you depends on this fragile liquid, this miracle molecule that is at once simple and infinite. It is gentle, but it shapes mountains. It is soft, but it holds the codes of life. It is common, yet it is extraordinary. The chemistry of water is the chemistry of you. And yet water is not the only element of transformation, for when molecules meet energy, a spark, a flame, a burst of light, they change in ways that carry heat, motion, fire. Water sustains life, but fire reminds you that chemistry is also motion, a restless dance of energy waiting in the dark. Fire and the dance of energy. You close your eyes and feel warmth on your skin. Combustion is chemistry in motion, a dance of oxygen and fuel. From stars burning above to candles flickering in silence, fire tells the story of energy. Every spark is a reminder that change is written into the fabric of matter. You have felt it since the beginning of memory, the glow of fire, the warmth of flame, the flicker that pulls your eyes into its dance. There is something ancient in fire, something that stirs both comfort and awe. But beneath its beauty lies chemistry in motion, the restless release of energy written deep into matter. Close your eyes and imagine a flame. It rises from wood or gas or a candle's wick. It wavers, it glows, it breathes. But what is fire really? Not a substance you can hold, not a thing you can weigh. Fire is a process, a transformation, a visible sign that bonds are breaking and new ones are forming. To understand fire, return to atoms and bonds. When two atoms share or exchange electrons, they hold energy in that bond, like a spring coiled tight. Energy is stored in the structure of matter, and when those bonds are rearranged, the energy is released, flowing into the air as heat and light. This is combustion, fuel plus oxygen, bonds breaking, bonds forming, the dance of energy set free. Take wood, for example. It is made of long chains of carbon, hydrogen, and oxygen, the scaffolding of cellulose and lignin that trees weave as they grow. When you bring a flame to wood, the heat excites its molecules, loosening bonds. Oxygen from the air rushes in, grabbing carbon and hydrogen, pulling them into new partnerships as carbon dioxide and water vapor. The rearrangement releases energy, which shines as flame, warms as heat, and spreads the dance to more of the wood. This cycle continues, feeding itself so long as fuel and oxygen remain. Too little oxygen and the flame sputters, too little fuel and it fades. But in balance the fire sustains, a delicate choreography of atoms exchanging partners, energy flowing outward with every step. In the flicker of a candle you witness this chemistry slowed, gentle, intimate. Wax made of hydrocarbons melts and wicks upward. The flame splits the molecules and oxygen embraces the fragments, sending light into the room, a soft beacon of matter becoming energy. Yet fire is not only warmth, it is transformation, irreversible and total. The wood becomes ash, the fuel becomes gas. Matter is not destroyed but changed, its bonds rewritten into new forms. And energy, always conserved, moves from chemical storage to radiant heat and light. Pause for a moment with that thought. Every campfire you've seen, every candle you've lit, every flame that has burned across the history of Earth is atoms rearranging, is stored sunlight being set free. For the energy of fire begins long before the spark. The wood that burns captured sunlight in its leaves, turning photons into sugar through photosynthesis. The sugars built cellulose, the cellulose built the tree. Inside those bonds lay the sunlight of seasons past, waiting quietly until flame returned it to the air. Fire is not destruction, but the release of captured sunlight, a recycling of energy written into the cycle of life. Now lift your gaze from the campfire to the stars, for the greatest fires of all burn in the heavens. The sun, the giver of daylight and warmth, is itself a furnace of unimaginable scale. But its fire is different. Here bonds do not merely break and form. Here atoms fuse. In the sun's core, hydrogen atoms are pressed together by gravity's crushing hand. 4 hydrogens fuse into 1 helium, and in that fusion, energy floods outward. This is nuclear fire, the deepest chemistry of the universe. The light you see, the warmth you feel, the life that thrives on Earth, all are gifts of the sun's atomic dance. So when you warm your hands by a fire, you are touching a story that began in the stars. The wood's bonds came from sunlight, the sunlight came from fusion, and fusion is the universe's first fire. Energy, then, is not just a flicker. It is a principle, a law, a thread running through all matter. It cannot be created or destroyed, only transformed. It shifts from chemical to thermal, from potential to kinetic, from stored to released. Even in your body, energy flows like fire slowed to a gentle ember. When you eat, your body takes in fuel, sugars, fats, proteins. You breathe oxygen just as fire does. Inside your cells, in tiny powerhouses called mitochondria, oxygen combines with food molecules. Bonds break, bonds form, and the energy is released, not in flame, but in slow, controlled steps. This is cellular respiration, a quiet fire that powers every heartbeat, every thought, every dream. You are in truth a living flame, not one that burns brightly and vanishes, but one that glows steadily, feeding on the chemistry of life. Think of how carefully energy is balanced. Too much heat in a fire, and the bonds break chaotically, releasing smoke, unburned fragments, soot. Too little, and the flame dies. Your body too walks this balance, releasing energy in measured amounts, never too fast, never too slow, a quiet rhythm of combustion within you. And energy is not only release, it is also motion. The heat of fire makes air rise, currents swirling upward, drawing oxygen in. The warmth on your skin spreads, molecules moving faster, vibrations quickening, light races outward, photons carrying energy across the room. Energy does not sit still. It is always in motion, always flowing, always transforming. Now imagine again the fire before you. Its glow flickers, its warmth radiates. It pulls your gaze, calms your thoughts, fills you with a rhythm older than language. For as long as humans have lived, we have gathered around flames. We have cooked, warmed, told stories, all while watching the dance of chemistry and light. Fire is both science and symbol, both reaction and ritual. And as you lie here, you can sense fire not only outside, but within. Your body is warm because of chemistry. Your thoughts are electric because of chemistry. Your very life is the slow burning of fuel, sustained by the oxygen you breathe in silence. You are a fire, an ember glowing in the dark of the universe. Energy surrounds you, shaping the world in ways both visible and unseen. It flows in the tides of oceans, in the winds that brush across mountains, in the lightning that splits the night sky. It pulses in stars, whispers in the bonds of molecules, and hums softly in the cells of your body. Energy is the thread that ties atoms and bonds together, that carries transformation forward, that gives matter its story. But even energy is not enough on its own. For energy needs a stage, a place where reactions unfold, a vessel where chemistry takes form. That vessel is your body. And to understand the chemistry of you, we must journey inward into the quiet reactions that keep you alive. The chemistry of the body. You drift inward into the rivers of your veins and the sparks of your neurons. Your body is not a machine but a living laboratory of constant reactions. Sugars, proteins, and hormones move like messages written in invisible ink. Every heartbeat is chemistry keeping you alive. You close your eyes and listen to your body. The quiet rhythm of your heart, the gentle pull of your breath, the soft warmth of your skin, all of it feels natural, as if it simply happens. But beneath the silence lies constant activity, a million chemical reactions happening each second, keeping you alive without your effort. Your body is not merely flesh and bone. It is a living chemistry set, a self-sustaining web of reactions that never sleep. From the tip of your hair to the beat of your heart, every part of you is made possible by molecules joining, breaking apart, and rejoining again. You are, in the most real sense, chemistry in motion. Begin with the breath you take in. Oxygen molecules enter your lungs, cross into your blood, and cling to hemoglobin, the iron-centered protein in red blood cells. Each hemoglobin is like a boat, carrying 4 passengers of oxygen at a time, sailing through rivers of veins to every corner of you. When oxygen arrives at your cells, it slips off the boat and into the busy city of life. There, inside tiny organelles called mitochondria, oxygen meets the food you've eaten. Sugars, broken down into simple glucose, enter a long and quiet pathway. Step by step, enzymes, molecular machines, pull apart bonds, release energy, and hand it over to molecules called ATP, adenosine triphosphate, the currency of energy, the small battery that powers every process in you. Without ATP, you cannot move, cannot think, cannot dream. But with it, your muscles contract, your neurons fire, your body keeps its warmth. Every blink, every sigh is paid for in ATP coins, and each ATP is made possible by oxygen meeting glucose in cellular respiration. Pause and feel your heart again. It beats not because you command it, but because chemical signals flow through it. Specialized cells in the sinoatrial node release ions, charged particles that shift across membranes, creating tiny waves of electricity. These signals spread through your heart, telling muscles when to contract, when to rest, when to contract again. Your heartbeat is not just rhythm, but chemistry flowing in time. The same is true of your thoughts. Every idea, every dream is a pattern of signals leaping across neurons. Neurotransmitters, chemical messengers, are released in one cell, drift across a tiny gap, and bind to the next. Dopamine brings reward, serotonin carries calm, acetylcholine sparks motion. Each is a molecule, each is chemistry writing meaning into the silence of your brain. Consider hormones, those slower, longer messengers of your body. Made in glands, carried in blood, they are molecules of instruction. Adrenaline rushes through when danger comes, quickening your pulse, sharpening your focus. Insulin whispers to cells to take in sugar, keeping your blood balanced. Melatonin, secreted as night falls, tells your body it is time for rest. They are small molecules, but they shape your moods, your growth, your sleep. Chemistry is not apart from your feelings, it is the foundation of them. Move deeper still to the proteins. They are long chains of amino acids, folded with exquisite precision. Each fold gives them power to cut, to carry, to build, to protect. Enzymes, special proteins, are catalysts, speeding up reactions that might take years into moments so fast you cannot perceive them. Without enzymes, digestion would stall, DNA would not copy, life would grind to stillness. With them, every reaction hums in harmony. Your DNA itself, the script of who you are, is chemistry arranged with elegance. A long ladder of nucleotides, adenine paired with thymine, cytosine with guanine, all held by hydrogen bonds. The bonds can unzip, allowing the code to be read, copied, expressed. Proteins are built from that code, and from proteins your body grows and repairs. DNA is not abstract. It is a molecule, a chemical library curled tightly in each cell. Even the immune system speaks in chemistry. Antibodies, proteins shaped like keys, fit onto antigens, foreign molecules carried by bacteria or viruses. The lock and key fit tells your body to defend. Other molecules rush in, histamines, cytokines, signaling inflammation, swelling, healing. The fight against illness is not only biological, but chemical warfare on a microscopic scale. And your senses too are all born from chemistry. Taste comes from molecules binding to receptors on your tongue, sweet sugars, salty ions, bitter alkaloids, each a molecule triggering a signal. Smell is the same. Tiny volatile compounds drift into your nose, where proteins recognize them, linking chemistry to memory, to emotion. Vision begins when photons hit molecules in your retina, twisting bonds, sending electrical signals that become images in your mind. Every sight, every sound, every flavor, all are chemistry translated into sensation. Think of movement. When you decide to lift your arm, calcium ions rush into muscle fibers. They trigger proteins, actin and myosin, to slide against each other, shortening the fibers, pulling bone. Movement is chemistry turned into motion. Every gesture you make, every step you take, is molecules pulling, releasing, binding again. Even your emotions are chemical. Love, fear, joy, sadness, all are shaped by molecules in your brain. Oxytocin floods when you bond, dopamine when you achieve, serotonin when you rest in contentment. These are not illusions, not separate from the physical. They are chemistry and experience braided into one. And yet, despite this vast web of reactions, you do not feel mechanical. You do not feel like a collection of molecules. You feel alive, whole, complete. That is the mystery of chemistry. From simple atoms and bonds, from molecules and messengers, emerges the richness of consciousness. You are not only chemistry, but you are also nothing without it. Take comfort in this thought. Every breath, every heartbeat, every flicker of thought as you drift toward sleep is chemistry working quietly, faithfully, endlessly. Your body is its own laboratory, always balancing, always transforming. You need not command it. It does its work in silence so that you may rest. As you lie here, you may wonder about the world beyond your skin. If chemistry is the language of your body, could it also be the language of your senses, the reason you feel a rose's fragrance, the warmth of fresh bread, the scent of rain on dry ground? The scent of the world. You imagine the sweetness of a rose, the sharpness of rain, the warmth of fresh bread. Scents are molecules finding their way into your nose, stirring memory and feeling. Chemistry is not only outside of you, but within your most intimate sensations. The air carries endless invisible stories, waiting to be breathed in. Close your eyes for a moment and imagine a memory. Perhaps it is the smell of the ocean, salt and seaweed carried on a breeze. Perhaps it is bread rising in the oven, warm and rich, filling a kitchen. Perhaps it is rain after a dry summer day, a scent so sharp and earthy that it feels alive. Each one begins not with thought, but with molecules floating invisibly in the air. Smell is chemistry meeting memory. It is the invisible world becoming intimate. Tiny molecules drift from their source, carried by the currents of air. They slip into your nose, into a narrow chamber lined with receptors. And here, chemistry becomes perception. Receptors are proteins shaped with care, each designed to catch certain molecules. When a molecule fits, it binds, and in that instant a signal is sent to your brain. Like a key turning in a lock, the binding of odor to receptor creates the spark of recognition. But the story is not simple. There are hundreds of receptors, each tuned to different shapes and charges. A single scent, say coffee, is not one molecule, but hundreds, each binding to different receptors in a pattern. Your brain receives this pattern like notes in a chord, and from it constructs the experience of smell. It is not one signal, but a symphony, molecules playing together to form aroma. This is why smell feels so detailed, why it can distinguish thousands of subtle differences. The fragrance of one rose is not the same as another, for each carries a slightly different blend of molecules, each creating a slightly different chord in your mind. Now imagine the journey of a single molecule. It leaves the surface of an apple, perhaps a volatile ester responsible for fruit's sweetness. It drifts through the air, invisible, weightless, until your breath pulls it inside. It finds its way to a receptor, binds, triggers a signal. Your brain receives it not as a molecule, but as the sudden freshness of apple, the vividness of fruit. This is the quiet alchemy of smell. What makes it remarkable is how closely smell is tied to memory. Unlike other senses, olfactory signals travel directly to the limbic system, the brain's seat of emotion and recollection. This is why the scent of a candle can bring back childhood in an instant, why the smell of a jacket can stir longing for someone far away. Smell bypasses reason and lands directly in feeling. It is chemistry made emotional. Even rain carries its own fragrance. When drops strike dry earth, they release compounds from soil and plants. One of them, called geosmin, is produced by soil bacteria, and your nose can detect it in astonishingly tiny amounts. The sharp freshness you breathe after a storm is not only sensation, but molecules announcing life in the ground. And the sea, too, has its chemistry. Dimethyl sulfide, released by plankton, carries the tang of the ocean air. It drifts into your lungs as you walk ashore, a reminder of life hidden beneath waves. Each place, each season is written in scent, a molecular signature of the world. Your body itself contributes to this orchestra. Pheromones, chemical signals, are released in sweat, in breath, in skin. Though faint and often below conscious detection, they influence attraction, comfort, recognition. Molecules carry stories of who you are to those around you. Pause and notice, your sense of taste is also incomplete without smell. Sweet, sour, salty, bitter, umami, these five are tasted on the tongue. But the rich complexity of flavor, the smokiness of tea, the spiciness of cinnamon, the ripeness of cheese, comes from scent molecules traveling retronasally from mouth to nose. What you call flavor is chemistry weaving together taste and smell. Smell even guides safety. The warning scent of spoiled food, the acrid bite of smoke, the sting of gas, all are molecules alerting you to danger. Chemistry protects you before thought can form, and in other ways, scent connects you to life's cycles. Flowers release fragrance to draw pollinators. Insects follow invisible chemical trails to food, to mates, to safety. Trees and grasses release molecules when wounded, carrying messages through air, sometimes even warning nearby plants to prepare defenses. The air you breathe is not empty. It is filled with messages, chemical words drifting without sound. As you lie in stillness, you can imagine the room around you alive with invisible stories. Wood gives faint molecules of resin, fabric holds subtle scents of cotton or dye, your own skin releases its signature blend. To your brain they may fade into the background, but to your body they are constant companions, a soft map of your place in the world. And yet, chemistry of scent is fragile. A single cold can block receptors, making food bland, memory quiet. With age, sensitivity changes, scents dull or shift, and the world feels subtly altered. It reminds you how deeply smell is woven into experience, how essential this invisible sense truly is. Take comfort now in knowing that every breath you take is also a conversation. You inhale molecules from trees, from oceans, from earth, and they speak to your receptors, whispering stories of place and time. The scent of the world is always flowing through you, even in silence. As you drift deeper toward rest, let yourself imagine this. Every scent, every fragrance, every trace in the air is chemistry in its most intimate form, molecules carried on breath, bridging matter and memory. And beyond scent, there are other forms of chemistry reaching your senses. not only the fragrance of molecules, but the glow of colors, light dancing off elements, telling their stories through brightness and hue. Colors from the elements. You watch light scatter into a rainbow across the night sky. Pigments and metals, crystals and gases all sing with color when touched by energy. Your eyes translate chemistry into beauty, a spectrum that tells the universe's tale. Every color is an element's secret signature, glowing softly in the dark. Close your eyes and imagine a rainbow arcing across the sky. 7 colors blend into one another, soft yet radiant. It feels like a painting, but it is not paint at all. It is light, bent and spread into its hidden spectrum. And behind that spectrum lies chemistry, the story of how elements speak in color. Color is born when light meets matter. A photon, a tiny packet of energy, strikes an atom or molecule. Electrons, those restless dancers orbiting the nucleus, absorb the photon if its energy is just right. Excited, the electron leaps to a higher level, a rung on the invisible ladder of energy states. But it cannot stay there forever. It falls back, releasing energy once more, and that energy escapes as light. The color you see is the element's reply, its unique signature written in the glow. This is why sodium lamps shine yellow, why neon signs blaze red, why copper burns green in flame. Each element has its own spacing of electron levels, its own rungs on the ladder. The distances between them decide the color of light released. Every hue is chemistry speaking in photons. Think of fireworks bursting against a night sky. Each flash of color is an element declaring itself. Strontium makes red, barium makes green, copper makes blue, sodium makes gold. What looks like celebration is, at its core, the dance of atoms absorbing and releasing light. Even stars carry their own colors. When astronomers look at starlight through a prism, they see dark lines crossing the rainbow. These lines, called absorption spectra, are fingerprints of the elements in the star's atmosphere. Hydrogen, helium, oxygen, iron, all leave their marks, telling us what stars are made of, what burns at their heart, what stories they hold. So when you gaze at the night sky, the twinkling is not only beauty. It is chemistry speaking across light years, color revealing the presence of matter in distant suns. Now return to Earth, to the pigments and colors you see each day. The green of leaves is chlorophyll, a molecule tuned to absorb red and blue light, reflecting green back to your eyes. Carotenoids reflect orange, anthocyanins reflect red, purple, blue. Every plant paints itself through chemistry, choosing which wavelengths of sunlight to drink, which to reflect, which to share as beauty. In your body too, color is chemistry. The redness of blood comes from hemoglobin, its iron center binding oxygen, shifting the color from deep purple to bright scarlet as oxygen comes and goes. The brown of your eyes, the color of your skin, the shade of your hair, all are pigments, molecules that absorb and reflect light in particular ways. Melanin, for example, is a complex polymer that shields you from ultraviolet rays, its chemistry written into the hues of your being. Even the blue of the sky is chemistry at play. As sunlight enters Earth's atmosphere, its photons scatter off nitrogen and oxygen molecules. Blue light with shorter wavelengths scatters more strongly than red. So when you look up, your eyes are filled with scattered blue. At sunrise and sunset, light travels farther through the atmosphere, losing blue and violet, leaving warm reds and oranges to paint the horizon. Every dawn and dusk is a reminder of molecules scattering light. Think of crystals too, minerals shaped in Earth's slow patience. Amethyst gleams violet because of trace amounts of iron. Emerald shines green through chromium. Ruby glows red from chromium as well, but arranged in a different lattice. Tiny differences in chemistry. Atoms replaced, electrons shifted, become gemstones that dazzle the eye. And metals, when heated, sing their colors. Iron glows red, then orange, then white as it warms. The glow is blackbody radiation, matter releasing light as its atoms vibrate faster and faster. You see this glow in the coil of a stove, in molten steel, in the embers of a fire. Temperature and chemistry combine to paint the world in radiance. Even color in everyday life is chemistry of light. The dye in your clothing is a molecule designed to trap certain wavelengths. Indigo binds deep blue, cochineal binds red, synthetic dyes weave rainbows into fabric. The paint on walls, the ink on pages, all are molecules carefully shaped to absorb, reflect, transmit. Color is chemistry domesticated, captured in bottles and brushes, woven into the fabric of your days. But notice, color is not in the object itself. It is in the interaction between light, matter, and your eyes. Without light, the world is dark, colorless. Without receptors in your retina, colors are invisible, untranslatable. Your eyes contain 3 types of cones, sensitive to red, green, and blue wavelengths. By blending these signals, your brain creates the spectrum of hues you know. Color is not only chemistry in matter, but chemistry in perception, a translation from photons to experience. This is why no 2 people see color exactly the same. Some are colorblind, their receptors tuned differently. Some perceive shades more vividly, their brains amplifying subtle contrasts. Color is universal yet personal, a chemistry shared, a perception unique. And there are colors beyond your sight. Ultraviolet, infrared, radio, X-ray, all part of the spectrum, all forms of light with different wavelengths. Bees see ultraviolet patterns on flowers, guiding them to nectar. Snakes sense infrared, detecting the warmth of prey in the night. Astronomers use X-rays and radio waves to study galaxies and black holes. The universe is awash with colors you cannot see, hidden chemistries of light beyond your eyes. Pause and breathe with this thought. Every color around you, every glow of dawn, every flash of lightning, every gem and leaf and star, is chemistry made visible. Electrons leaping, photons flying, molecules absorbing and reflecting, a constant silent fireworks of existence. You live in a world painted by chemistry, not abstract, not distant, but immediate, intimate. The green of grass beneath your feet, the gold of sunlight warming your face, the red of a loved one's smile. All are stories of atoms and energy, translated into beauty through your eyes. And yet color is only part of matter's hidden language, for beyond what you see, beneath the surface of Earth itself, chemistry shapes stone, crystal, and metal. Deep underground, elements arrange themselves into structures that build mountains, store heat, form tools, forge civilizations. The next chapter of the story waits there, beneath your feet, in the metals, stones, and Earth's hidden heart. Metals, stones, and Earth's hidden heart. You journey underground, where elements sleep in ores and crystals. The Earth's crust is a vast storehouse of metals and minerals shaped by time. Gold gleams, iron strengthens, silicon computes. It is chemistry that builds civilizations. Beneath your feet, the slow alchemy of pressure and heat continues. Close your eyes and imagine sinking downward, through soil, through rock, into the hidden depths of Earth. Above you is sky, light, color. Below you lies darkness, pressure, silence. A world built from metals and minerals, the chemistry of stone. The crust beneath your feet is not lifeless. It is a record of Earth's history, written in layers of rock, in crystals formed by cooling magma, in ores pressed into veins by ancient waters. Every stone you touch carries the memory of chemistry, the slow, patient rearrangements of atoms over millions of years. Begin with metals: iron, copper, silver, gold. Names so familiar they feel eternal. Each is an element forged in the hearts of stars long ago, scattered as stardust, gathered into Earth when it was young. Now they sleep in veins, waiting to be discovered, waiting to become tools, coins, wires, jewelry. Iron is the most abundant of them. In your blood it carries oxygen, but in Earth it forms ores, hematite, magnetite, rust-colored rocks heavy with potential. When smelted in furnaces, iron atoms are freed, rearranging into alloys like steel. It is this chemistry that built bridges, skyscrapers, railways, a civilization rising on iron's shoulders. Copper too lies in stone, its atoms glowing reddish-orange when pure. Soft, malleable, and an excellent conductor, copper became humanity's first metal. Beaten into tools, drawn into wires, it carries electricity, the quiet rivers of electrons that light your room and power your devices. The chemistry of copper is the chemistry of civilization's spark. Then there is gold, so rare, so resistant to corrosion, it shines unchanged through centuries. Gold atoms do not tarnish or rust, their electrons too tightly bound to yield. This stability gives them their luster, their permanence. It is why gold has been treasured, why it adorns crowns, coins, temples. Gold's chemistry is eternal youth, its surface never dimming, its glow never fading. And silver, a mirror among metals. Its surface reflects nearly all light, making it radiant, almost liquid in shine. For centuries it has been used in mirrors, in photography, in coins and adornments. Silver's gift lies in electrons free to move, turning the metal into both conductor and mirror. Aluminum, though common, hides differently. It bonds tightly to oxygen, locked in ores like bauxite. Only through electricity, through coaxing bonds apart, can aluminum be freed. Lightweight, strong, resistant to rust, it became the metal of flight, the wings of airplanes, the frames of spacecraft. The chemistry of aluminum is chemistry of horizons, stretching into sky and space. And beneath all metals lies silicon, the quiet architect of Earth's crust. Second only to oxygen in abundance, silicon binds with oxygen to form silicates, the minerals that make most of the rock beneath you. Quartz, feldspar, mica, all are lattices of silicon and oxygen arranged into repeating crystals. Silicon is not only stone, it is also the heart of computation. In purified wafers etched with circuits, it becomes the brain of machines. The stone beneath your feet is also the code in your pocket. Now shift your attention to the crystals, those patient geometries of atoms. A crystal forms when atoms arrange in order, repeating patterns stretching outward. Quartz grows six-sided, amethyst gleams purple with iron traces, diamond glitters with carbon in perfect symmetry. Each crystal is chemistry frozen in order, atoms locked into repeating embrace. Pressure and time deepen the story. Deep underground, atoms are pressed by weight, heated by Earth's molten heart. Carbon, squeezed for millions of years, becomes diamond, the hardest material known, atoms held so tightly that light scatters brilliantly through them. Other minerals too are born this way, garnet, sapphire, emerald. Each is a testament to chemistry sculpted by patience. Consider limestone, built from shells of ancient creatures, compressed into rock, then transformed by heat into marble. The white stone of temples and statues was once the skeletons of tiny ocean lives. Chemistry rearranges but never forgets. Even the soil beneath your hand is chemistry unfolding. Minerals break down, releasing nutrients for roots. Clays hold water, their charged layers binding and releasing ions. The ground that feeds crops, that sustains forests, is a stage for the chemistry of earth and life entwined. The stones and metals beneath you are not only resources, they are memory. They carry the record of Earth's formation, of magma cooling, of seas rising and falling, of continents colliding. Every rock is an archive, every mineral a page in Earth's story. And yet humanity has always reached for them. We smelted copper, forged iron, minted silver and gold. We built with limestone, carved marble, cut diamonds. Our cities are chemistry in stone and metal, our progress a dialogue with Earth's hidden heart. But the heart of Earth beats deeper still. Beneath the crust lies mantle, molten rock convecting slowly, carrying heat outward. Beneath that, the core, outer core liquid, inner core solid, both made mostly of iron and nickel. The movement of liquid iron creates Earth's magnetic field, shielding you from solar winds, allowing life to thrive. Even unseen, Earth's metals shape your days. Pause and reflect. You are never separate from the stone beneath you. The calcium in your bones, the iron in your blood, the zinc in your enzymes, all came from Earth's crust, from rocks weathered, from soil nourished, from chemistry carried into food and water. You are not only stardust, you are also earth dust shaped by minerals beneath your feet. As you rest in thought, you may imagine a jewel, a diamond on a ring, a ruby in a crown, a sapphire in a necklace. To the eye they are beauty, but to chemistry they are lattice and element, arrangements of atoms under pressure. The treasures we prize are chemistry slowed to stillness, geology turned into adornment. And yet the ground holds more than beauty. It holds energy, coal, oil, natural gas, all born from ancient life compressed in stone. It holds uranium, its atoms unstable, releasing energy through fission. It holds geothermal heat, the restless warmth of Earth's mantle. Metals, minerals, fuels, all are Earth's gifts and Earth's responsibilities. You are part of this balance. The devices you use, the buildings you enter, the paths you walk, all depend on metals and stones. Every wire, every brick, every screen is chemistry drawn from Earth's crust. The hidden heart sustains your visible world. But remember, the crust beneath your feet is only a beginning. Beyond Earth, chemistry waits in wider emptiness, in clouds of gas and dust between the stars. If metals and stones tell Earth's story, then interstellar atoms tell the universe's. Even in the thin spaces between suns, chemistry endures, writing the beginnings of new worlds. The air between stars. You float beyond Earth into the thin cold where chemistry still persists. Interstellar clouds cradle hydrogen and carbon, the seeds of new worlds. Even in near emptiness, atoms collide, bond, and break apart in cosmic patience. You realize chemistry is not just Earth's language, but the universe's breath. Close your eyes and imagine rising higher, past the trees, past the clouds, past the blue sky fading to black. You leave the Earth behind, crossing the silence where the atmosphere thins, and soon only the stars remain. At first glance, space looks empty, a vast darkness dotted with light. But space is not void. It is filled with whispers of chemistry, the faint breath of atoms drifting between the stars. The air between stars is not air as you know it. It is far thinner, far colder, so empty that a single cubic centimeter may hold just a handful of atoms. Yet those atoms, hydrogen, helium, carbon, oxygen, are the seeds of galaxies, the raw ingredients of planets and life. It is in this seeming emptiness that the story of chemistry continues. Begin with hydrogen. It was the first element, born in the furnace of the Big Bang. Even now it is the most abundant, making up most of the matter in the universe. In the interstellar medium, hydrogen drifts as single atoms or pairs into H2 molecules, chilled to near absolute zero. These molecules gather in clouds, vast invisible oceans of gas stretching light years across space. Within these clouds something remarkable happens. Though collisions are rare, though centuries may pass between two atoms meeting, time in the cosmos is endless. Given enough years, hydrogen joins with carbon to form simple molecules, carbon monoxide, methane, formaldehyde. Even water vapor hides in these clouds, frozen or drifting, waiting for the warmth of a star to release it. These are not trivial reactions. They are the beginnings of complexity, the first steps toward life. In certain regions, organic molecules, chains of carbon and hydrogen, are detected in the interstellar medium. Amino acids, the building blocks of proteins, have been found in meteorites, hinting that chemistry's patience can create the seeds of biology even in the dark. Now imagine a nebula, a glowing cloud where stars are born. Here gravity pulls gas together, densities rise, temperatures climb. Hydrogen fuses into helium, igniting the nuclear fire of a new star. But not all matter falls inward. Much remains as a disk, dust and gas, circling, colliding, sticking, forming rocks, then planets. The chemistry of interstellar space becomes the chemistry of worlds. The Orion Nebula, visible even with small telescopes, is such a birthplace. Glowing pink and violet from ionized hydrogen, it cradles newborn stars. Spectroscopy, the study of light's fingerprints, reveals carbon, nitrogen, oxygen in its clouds. Astronomers look at those colors and see chemistry, atoms shouting across space, "I am here, I am part of this." But even far from stars, chemistry whispers. In cold, dark clouds, dust grains serve as laboratories. Atoms land on their surfaces, stick, move, combine. Hydrogen meets oxygen to form water. Carbon meets nitrogen to form cyanides. Molecules too fragile to exist in the wild of space can form on these grains, shielded from radiation, before drifting off again. Tiny specks of dust become the wombs of interstellar chemistry. Consider the journey of one such grain. It forms around a dying star, expelled into space with carbon and silicon. It drifts for millions of years, passing through clouds, gathering ice and molecules on its surface. Eventually, it falls into a young solar system, becoming part of a comet. When that comet strikes a planet, it delivers water, organics, seeds of life itself. The air between stars is not emptiness, but a courier of futures. Think now of supernova, the deaths of massive stars. When they explode, they scatter heavy elements into space. Iron, gold, uranium, all forged in the heart of stars, then flung outward in a storm of debris. This debris enriches the interstellar medium, so that new stars, new planets, form from stardust already rich in chemistry. Without death, there would be no diversity. Without supernova, there would be no you. Astronomers study this through light. A cloud invisible to the eye reveals itself in radio waves. Carbon monoxide glows in millimeter light, a tracer of cold molecular gas. Hydrogen emits faint signals at 21 centimeters, a line used to map galaxies. Infrared telescopes peer through dust, finding water, organics, complex chains. Every wavelength is a language, every photon a messenger of chemistry in space. You may ask, why does chemistry persist in such emptiness? Because atoms cannot resist their nature. They attract, they bond, they form and break and form again. Even with centuries between collisions, given billions of years, the improbable becomes inevitable. Time is the reagent of the cosmos. And so chemistry in space mirrors chemistry on Earth. Water forms, carbon chains grow, molecules carry energy, bonds store and release it. The difference is only scale. On Earth, reactions race in seconds. In space, they unfold across millennia. But the rules are the same. The bonds that hold you together are the same bonds that shape the clouds between stars. Imagine yourself drifting in one such cloud. All around, atoms float in silence. You cannot hear them, but you know they move. Occasionally, two meet, cling, release light. Each spark is too faint for your eyes, yet multiplied across billions, they light entire nebulae. You are surrounded not by nothingness, but by the slow heartbeat of the universe. And from this chemistry, life may arise again and again. If amino acids can form in the darkness of space, if comets can carry them to planets, then perhaps the seeds of life are scattered everywhere. Perhaps the air between stars is also the soil of galaxies, where the chemistry of existence is sown. Pause and let this thought settle. You are breathing the same elements that once drifted between stars. The oxygen in your lungs, the carbon in your skin, the iron in your blood, all began in interstellar clouds. You are not only made of stardust, you are made of the air between stars, gathered, condensed, reborn. As you drift into rest, you might sense that this chemistry, patient and eternal, is also a clock. Atoms decay, molecules rearrange, stones weather, bodies age. Time itself is chemistry in motion, the endless transformation of matter. And the next story waits there, in the chemistry of time. The chemistry of time. You return to the flow of years, where chemistry writes the story of change. Rust spreads, fruit ripens, skin weathers. Time is chemistry at work. Radioactive decay whispers the age of rocks and stars alike. Through chemistry you see how the past, present and future are written into matter. Time feels invisible. You cannot hold it in your hands. You cannot see it flowing past. And yet you know it deeply, for your body, your memories, your world are all shaped by it. Time is not only clocks ticking, not only days passing. Time is chemistry unfolding. Consider a piece of iron left in the rain. At first it gleams, strong and solid. but slowly moisture and oxygen reach its surface. Electrons flow away, iron atoms lose their balance, and reddish flakes of rust spread. This is oxidation, a reaction of metal and air, and it is chemistry's way of marking time. Or think of fruit hanging on a tree. When unripe, it is firm, bitter. But enzymes, proteins folded to speed reactions, begin their quiet work. They break starch into sugar, soften cell walls, release fragrant molecules. The fruit ripens, sweetens, beckons, and left too long, other reactions take over, microbes digesting sugars, flesh softening into decay. From unripe to ripe to rotten, the journey of fruit is chemistry across time. Your body too shows the marks of chemical change. Skin wrinkles as collagen, the protein that keeps it firm, cross-links and stiffens. Hair grays as pigment molecules slowly fade from follicles. Cells accumulate tiny damages, molecules lose their perfect function. Aging is not separate from chemistry. It is chemistry's clock within you, ticking not in hours, but in molecules rearranged. Even mountains age, though their time is vast. Rocks exposed to wind and rain slowly weather. Carbon dioxide in air dissolves in rainwater, making carbonic acid, which seeps into stone, breaking minerals into clay and ions. Valleys widen, peaks crumble, grains of sand wash to sea. Geology is chemistry slowed to the pace of centuries, but still, it is change. Time is also revealed through radiation. Deep within atoms, nuclei sometimes break apart. An unstable isotope decays, releasing particles and energy. This happens with perfect regularity, each isotope with its own half-life, a measure of how long it takes for half of a sample to change. Uranium becomes lead, carbon-14 becomes nitrogen. By measuring what remains, scientists read the ages of rocks, the age of fossils, even the age of the Earth itself. Radioactive decay is chemistry's calendar, written into the atoms themselves. The story extends to stars. As they burn, hydrogen fuses into helium, helium into heavier elements. Over billions of years, the balance of elements shifts. Astronomers read starlight to measure their age, to know whether they are young and blue or old and red near the end of their fuel. Stars age by chemistry, their brightness and color a record of time's passage. Now return to your own sense of time. Why does memory feel like a flow? In your brain, molecules shift, proteins strengthen or weaken connections between neurons. Each experience leaves a trace, a new arrangement of molecules in synapses. Your memories are chemistry, patterns of molecules reshaped with every thought. And as memory grows, so does your sense of time. Past and future are not only imagination, they are chemistry written into your brain. Even your circadian rhythm, the sense of day and night, is molecular. In each cell, genes turn on and off in cycles. Proteins rise and fall in concentration, setting a rhythm close to 24 hours. This chemistry is synchronized with light, with the rising and setting sun, so that you wake and rest in tune with the world. Time in your body is not measured by clocks, but by molecules dancing in cycles. Pause and imagine time not as a river, but as a series of reactions. Atoms bond, break, rearrange, molecules form, degrade, reform. The world changes because matter never rests. Rust, ripening, aging, weathering, all are chemistry keeping time. Yet time is not only decay, it is also creation. Seeds sprout, proteins fold, stars ignite. Each beginning is chemistry in action, time written forward in bonds newly made. Change is not loss but transformation, a constant cycle of becoming. The chemistry of time holds mystery too. Why do reactions move forward, not backward? Why does rust not unspool into shining iron again? Why does fruit not leap from decay to ripeness? The answer lies in entropy, the tendency of systems to move toward disorder. Energy spreads, heat dissipates, molecules drift to randomness. Entropy gives direction to time, an arrow pointing forward, a reason why you remember yesterday but not tomorrow. And yet, in the midst of entropy, life holds order. Cells build proteins with precision, DNA copies itself with accuracy. Energy from the sun allows plants to weave order from chaos, to grow forests and flowers. Life is chemistry resisting disorder, local islands of order in a universe of spreading entropy. But even life must eventually yield, for entropy always wins in the end. As you rest in thought, you may notice the comfort in this. Every wrinkle, every weathered stone, every decayed leaf is part of chemistry's time. The atoms remain, the elements persist, only the arrangements shift. Nothing is lost, only changed. And so time is not a thief, it is a chemist, rearranging molecules, writing new stories from old matter. Your body, your world, your universe, all are experiments unfolding, patient, inevitable, beautiful. Imagine now holding a stone in your hand. It feels solid, eternal. But within, atoms are restless, bonds slowly shifting, minerals changing grain by grain. The stone is not fixed. It is simply aging too slowly for you to see. Everything around you is chemistry in motion, time written into matter. And when you think of the future, you imagine chemistry not yet done. Iron will rust, stars will burn out, galaxies will thin. But new bonds will form, new stars will ignite, new molecules will rise. Time is chemistry's promise that change will always come. As you drift deeper into rest, let yourself feel the rhythm of time in your own body, the slow beat of your heart, the steady flow of your breath, the warmth of your skin. All are reactions keeping time. Your body is a clock, not of gears and hands, but of chemistry unfolding quietly. And beyond you, life too depends on balance over time. Too much of one element, too little of another, and the delicate rhythm falters. The next chapter waits here in life's fragile balances, where chemistry walks the line between growth and collapse. Life's fragile balances. You reflect on the thin line between creation and collapse. Too much or too little of one element can change the course of life. Balance is delicate, like air held in a bubble or oxygen in a flame. All living things are bound by chemistry's tender equilibrium. Life is delicate. You feel its strength in your heartbeat, in the steady pull of your breath, yet you know it can be interrupted by the smallest shift. Chemistry sustains life, but it must do so in balance. Every cell, every ecosystem depends on the fine-tuned proportions of molecules and elements. Too much, too little, and the balance falters. Begin with oxygen, the breath you take without thought. You need it, for it fuels the reactions inside your cells. But too much oxygen and it becomes poison. High concentrations create reactive oxygen species, unstable molecules that damage proteins, break DNA, erode the very structures that sustain you. So your body regulates, taking in enough to burn fuel, but not so much that you burn yourself. Balance is survival. Water too is a story of balance. You are mostly water, yet even a small loss dehydrates you. Cells shrink, blood thickens, organs strain. But too much water and the delicate balance of salts in your blood dissolves, nerves misfire, and the body falters. The chemistry of life is not water alone, but water in harmony with electrolytes, sodium, potassium, chloride, all held within narrow ranges. Consider the pH of your blood. It hovers around 7.4, just slightly alkaline. If it drifts even a little, cells fail. Enzymes, those folded proteins that drive reactions, work only in this narrow window. Too acidic and they unravel, too alkaline and their shape falters. So your body carries buffers, bicarbonate, proteins, phosphates, chemical guardians that keep pH steady. Without them, life would dissolve in imbalance. Now shift to glucose, the sugar carried in your blood. It is fuel, the energy source for every cell. But it too must be balanced. Too little, and your brain stumbles into confusion. Too much, and over time blood vessels stiffen, nerves fray, organs weaken. Insulin and glucagon, two small hormones, move in rhythm, keeping glucose steady. A seesaw held in balance by chemistry's hand. In your body, this balance is constant vigilance. Hormones rise and fall, enzymes activate and rest, ions move across membranes, all to keep equilibrium. This is called homeostasis, the chemistry of stability in the midst of change. Your body is a living balance beam, never still, always adjusting, always returning to center. Ecosystems too live in balance. The air holds just enough carbon dioxide for plants to breathe in and build sugar, just enough oxygen for animals to live. Forests release oxygen by day, consume it by night, maintaining a rhythm with the atmosphere. Oceans absorb carbon, but not too much, for too much makes them acidic, weakening shells and corals, tipping ecosystems toward collapse. Earth itself is a vast balancing act, its chemistry delicately poised. Think of nitrogen, the element most abundant in air. It is inert, a quiet backdrop, until bacteria capture it, turning it into ammonia, nitrates, nitrites, forms plants can use. Too little and crops fail, forests starve. Too much and rivers bloom with algae, fish suffocate, waters die. Fertilizer feeds billions, but excess tips balance into harm. Pause and reflect. Life is always between extremes. Heat and cold, acid and base, oxygen and carbon dioxide. Each must be balanced like the tension in a string pulled just right. Pluck it too tightly and it snaps. Leave it too loose and it cannot sing. Life is the string tuned to harmony. Even inside a single cell, balance governs. Ions like calcium flood in only when signals demand it. Too much calcium kills, too little, and signals fail. Proteins fold only in precise conditions, their delicate shapes disrupted by temperature shifts. DNA is copied faithfully, but if errors accumulate too fast, disease follows. Balance is not abstract. It is the daily reality of chemistry holding you together. And balance is fragile. Small disruptions can ripple outward. A single mutation alters a protein misfolds, an enzyme loses function, a pathway falters. From this, illness arises, cancer, diabetes, neurodegeneration, all from chemistry tipping away from center. Yet balance is also resilient. Your body repairs, enzymes refold, antioxidants neutralize free radicals, immune cells restore equilibrium. Life bends, adjusts, compensates. For balance is not stillness, but constant movement around a center. It is chemistry's quiet dance of correction. Ecosystems too can heal. A forest burned by fire regrows, its soil enriched with ash. A coral reef stressed by warming can recover, if waters cool and time is given. Balance is fragile, but it can return, so long as chemistry is allowed to settle again. Now imagine standing at the shore. The waves rise and fall, neither flooding nor retreating completely. This is balance, the rhythm of tide, the meeting of ocean and land. Life is like this, a tide of molecules, always in motion, always returning to a line. In your own body tonight, balance continues. Your kidneys filter blood, removing excess salts, retaining what is needed. Your lungs release carbon dioxide, holding pH steady. Your liver processes toxins, keeping blood pure. You need not think of these acts, they happen quietly, chemistry guarding you. But consider, this balance extends beyond you. Your breath exhales carbon dioxide, a gift to plants. Plants release oxygen, a gift to you. Your body depends on ecosystems, and ecosystems depend on Earth's cycles. Balance is not personal, it is universal. And in the universe too, balance holds. Stars burn steadily for billions of years because fusion and gravity balance each other. Too much gravity and stars collapse. Too much fusion and stars explode. Only in balance do they shine. Even galaxies spiral in equilibrium, gravity countering centrifugal force. Balance is written everywhere, from the smallest cell to the grandest star. Pause now and take a breath. Inhale oxygen, exhale carbon dioxide. Your lungs adjust gas levels, your blood buffers pH, your cells fuel themselves, all in a single breath. Balance is not abstract, it is this moment, sustaining you as you rest. But chemistry's balances are not eternal. They can shift, sometimes gently, sometimes suddenly. And when they do, new forms arise, species evolve, ecosystems adapt, stars collapse into new structures, balance breaks, and from it, new balance emerges. So life's fragile balances are not chains, but pathways. They are the way matter moves forward, ever adjusting, ever seeking a new equilibrium. Balance is not the end of change, it is the condition that allows change to continue. As you drift deeper, let yourself feel gratitude for these balances, the chemistry that holds your body, the chemistry that shapes your planet, the chemistry that steadies the stars. For without balance there would be no life, no thought, no rest. And yet balance is only part of the story. What about the origin of the atoms themselves? If you are made of balanced chemistry, where did those atoms come from? The answer lies in the stars, and in the stardust that became you. You made of stardust. At last you return to yourself, breathing, sensing, resting. Every atom in your body was forged in a star long ago. You are not separate from chemistry, you are its finest experiment. As you drift to sleep, you rest within the endless story of matter. You are lying in stillness, breathing softly. The stories of atoms, bonds, water, fire, and life have carried you far. But now they bring you home, back to your body, back to your being, back to the chemistry that makes you. It is easy to feel separate, a small creature on a small planet. Yet you are not apart. Every part of you is matter borrowed from the universe. Every atom in you carries a history older than Earth itself. You are not only alive, you are ancient. Consider the carbon in your skin. Each atom was forged billions of years ago in the furnace of a star's core. There, hydrogen fused into helium, helium into carbon, carbon into heavier elements. When the star reached the end of its life, it released its treasure in a supernova, flinging carbon, oxygen, iron, gold across the galaxy. That debris drifted for eons, gathering into clouds, forming new stars, new planets, and eventually Earth. The iron in your blood once pulsed in the heart of a dying star. The calcium in your bones was born in stellar fusion. The oxygen you breathe was forged in cosmic fire. Every piece of you is stardust, not metaphorically, but literally. Pause with this thought. The stars you see tonight are kin to you. You carry their atoms. Their chemistry became your chemistry. The universe has written itself into you. From stardust to Earth, the journey continued. Atoms gathered into oceans, into rocks, into air. Through billions of years, life emerged, molecules folding into cells, cells into organisms, organisms into ecosystems. You are one thread in this vast fabric of chemistry, woven from the same cloth as all life. And yet, you are not only stardust, you are stardust that can think, that can reflect, that can ask, where did I come from? Why am I here? What does it mean to exist? Your brain, itself chemistry in motion, turns atoms into questions, molecules into memory, neurons into imagination. You are matter that contemplates its own origin. You are chemistry that has become aware of itself. Consider the flow of atoms in you now. The oxygen you inhaled a moment ago was exhaled by trees earlier today. The water in your cells was once part of a glacier, a river, a raindrop. The carbon in your muscles was once in a loaf of bread, a stalk of wheat grown under the sun. You are not a closed system, you are part of a cycle, borrowing atoms for a time, returning them when your turn ends. Even now, as you rest, your body is exchanging atoms with the world. You inhale, you exhale, you drink, you release. Every day, atoms come and go. The body you think of as you is never the same from moment to moment. And yet the pattern endures. You are not the atoms themselves, but the dance they perform together. Your identity is chemistry's continuity, not chemistry's stillness. This is the humility and wonder of being. You are built from what was once scattered. You are sustained by constant exchange. You are not separate from the universe. You are the universe made small enough to breathe, to feel, to dream. Think of your heartbeat now. With each pulse, blood flows, carrying oxygen and nutrients, carrying atoms across your body. It is as if your body were an orchestra, each molecule playing its part. The music is not written down, but emerges from balance, from connection, from chemistry. You are music, played on the instrument of stardust. And what of the future? Your atoms will not remain in you forever. One day they will return to soil, to air, to water. They will be taken up by other lives, plants, animals, perhaps new generations of humans. Your atoms will scatter again, just as they scattered from stars. They will travel, they will bond anew, they will form new beings. Your chemistry will not end, it will only change form. There is comfort in this. You are temporary in body, but timeless in matter. You are part of the eternal cycle of atoms moving through space and time. The stardust that once burned in stars now beats in you. And when your time passes, it will continue its journey, joining other stories, other lives. Even now your thoughts ripple outward. The breath you exhale spreads molecules into the air, to be breathed by others, to circle the earth. Your influence is not only abstract, it is chemical. You are woven into the world in every moment, whether you notice it or not. As you drift into rest, let yourself feel small, and at the same time, infinite. You are a single being, yet also a cosmos in miniature. Your body is galaxies of molecules, your mind is constellations of thought. You are the universe made intimate. This is the chemistry of you, atoms from stars shaped into a body, woven into life, capable of wonder. It is not separate from you, it is you. And so, when you look at the night sky, you are not gazing at something distant. You are seeing family. The stars above are cousins, the galaxy's kin, the atoms shared. The universe is not outside you, it is within you. Rest now in this truth. You are made of stardust. Every breath is the universe breathing. Every thought is the universe thinking. Every heartbeat is the universe alive. Let sleep take you gently. Let your body sink into stillness. The chemistry within you continues, faithful, unbroken, carrying you into dreams. The atoms of stars have found a home in you, and through you, the story of matter continues.